Good morning. My system isn't working this morning, so I just have to, I'm coming on via my phone. If I can make it level for you. And I've just got to do a quick share because the other system didn't work. So I'm just going to cancel that completely. Waste of time. And just do a very, very, very quick share. So, go there. So today we're doing shifting times tables. Shifting times tables? Times tables, shifting, shift. Why would you shift a times table? Interesting question. So, just sharing. Apologies, slightly late. Technology didn't work. So, when that happens, doesn't it? That's a 21st century reality of life. So here we go. I am going, yes, here we go. Going to do a quick share and share. I kind of got, what's the word? I got a bit overconfident. Have you ever got overconfident? Because it's been working every single day, so I thought it'll work, and then it didn't. So this is my backup. Shifting times tables. Shifting times tables. So why do you think we're calling it shifting times tables? Why do you think, not a group, why do you think, why shifting? Why are we shifting times tables? I have to confess, I did not know that until I looked at the Aiming High resource and went over it. And now I know why, and it's quite a big surprise. So this is about learning times tables, but it's also about how the times tables actually become useful in different ways. Now, I did say last night that I would reveal that today, and I will. And I'm going to do one more thing, which is share that, play that, and share it myself on my own Start Watch Party. You have to actually select. I thought you just press Start Watch Party and it started. It doesn't work that way. You've got to select. You probably know all this. But then it's all greyed out, so I can't do anything with it. So I won't worry about it. I'll just... Now it won't let me look at anything. Woo! Oh, okay. Shared to my timeline. It's confused. Cancel, escape. Right, all I can do is look at this one here. So I'll look at this one here. Right, okay. Everything's gone a bit skew-iff now. Okay. Facebook.com. That's Yvette. That's our lovely Yvette.
This is our lovely Caroline.
Good morning, everyone. Right. Okay. I don't know what's going on. I'm going to ignore that. You know what? Just for once, we're just going to have us on the group, on the Making Maths Fun for Kids of All Ages group, and it is about times tables. So the first, if you've got any learners in your home or in your that are just learning, starting off, getting to grips with numbers, then a great way for them to start learning their times tables and get a feel for it. It's not about, we want to do two things. We want to have a feel for numbers. It's called number sense. It has a name, number sense. So we want to get a feel for numbers, okay? So if you're just learning your numbers, then we want you to get a feel for them. And you know what we're going to do? We're going to clap and we're going to dance and we're going to do a bit of rhythm and stuff. So what you're going to do is start counting. Well, you already know how to count if you're young, and then we're going to be clapping. We're going to be doing that at 10 o'clock in 55 minutes. We're going to be doing that, and so please come back in 55 minutes, and we're going to be just moving around and clapping and dancing to numbers, so we get a feel for them inside. And yes, so that's, sorry, I was looking at the wrong page. I thought, no, that can't be for early years. Oh dear, the things I do to myself. Right, so It happens every time. Page 3. Page 3 just disappears. I had it ready. I had it in my hand. And page 3 has disappeared. This is what we're going to do starting right now. If page 3 hadn't disappeared. Okay, here's a second copy of page 3. Here we go. So what we're going to do is, that's what we're going to do for the littlies, is just really just clap and move. But we are going to do some clapping if you are 7 and up. And this is great if you can get everyone in the same place. So if you were in a class, you do the whole class, and you could even have the whole school doing this. You can have a clapping rhythm concert all about numbers. Again, it's all about getting a feel for numbers and getting your senses going and understanding numbers and feelings. So when you hear a 4, you know how it fits in with all the other numbers. So what we're going to do, if you've got 5 people in your home, then you can do this. So you just start counting. So one person counts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next person does the 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The next person, guess what? Does the 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the next person, if you've got 6 people, it works if you've got lots of people. If you've only got 2 people, you can just do a 1-to-1 clap. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what you'll find, you might get surprises, you might get, well, you have a lot of giggles, because if you've got someone like me in your group, then they'll be clapping at the wrong time. But you know what? If you practice, you all get, and you take turns in doing the different rhythms on the different beats, the different numbers, the different spacings, then you get it gets those numbers inside you. You have fun, and you start getting it. Now you could do that on your own. You could do 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't have to say it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And one of the things, if you, and then to make it fun as well, and you can just do it with 2 of you. You can just do it with 2 of you just to practice your times tables. So you can have just 2 of you and see when you're, and not just clap, but also stand up and sit down. So if you can do an actual concert, and it's really beautiful if there's lots of you. But if there's only 2 of you, then, or even just 1 of you, you can just do it and get some exercise at the same time. So you can go, like, if you were doing a big concert with lots of people, you'd have one person standing up and they'd have number 1. So there'd be 1, 2, 3, 4, 5, 6, and then you don't have to do the clapping. You can just do the standing up. So the 1, 2 person would be 1, 2. Actually, that's the same. So actually, the 1 person will be 1, 2, 3, 4. The 2 person will be 1, 2, 1, 1, 2. See, I told you. 3, 4, 5, 6, and the 3 person will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, might have to do a bit more slowly to be able to stay caught up. And it's great exercise as well. So maths and exercise, and so that's a way to just start getting the numbers, a feel for the numbers and how they work together and the rhythms. And then what you'll observe is who is standing up at the same time. And when you do, one of the things you find out the common factors in numbers. You find out the beats of numbers when everybody's standing up at the same time. Will everybody all be standing up at the same time ever in the whole time? Great one to film. And so there's some other ideas on the activity. So on the activity pack that you want to download, it's on it's got its own post today for the activity pack. There's lots of ideas you can do. Now if it's just, as I say, if it's just 2 of you, just go with beats. 1 could do 2, 1 could do 4, 1, 2, and then and then the other one 4. You could just decide what numbers you want to do and do the jumping up and down and get the exercise. Now, that's a fun activity. Now, we're not, at the same time, you do want to be learning your times tables. I'm just looking for the right sheet of paper here. You do want to be learning your times tables. You want your times tables to be something that when you think, what's 6 sevens, and you just have the number. It just comes to you. Now, I still haven't reached that point because I didn't do this when I was a child. I didn't do what you're doing right now when I was a child. And I'm just learning now. I'm just learning my times tables now. Because up till now I have to work them out. So what 6 sevens I have to work out. I know what 6 sixes are. And then I have to add another 6 onto 6 sixes. So that's how I work out what 6 sevens are. I don't know it. Now that holds me back. That means that if I see numbers together, I don't recognize patterns as well. Hello, somebody sent some love. Hello, do let us know who you are because I can't see. All I've got is I see 5 people and I don't know who you are. So maybe that was Grace. I'm just wondering if that was Grace when I mentioned having difficulty with my times tables. So what you do, we do encourage you to learn your times tables, and the great way to do that is with number rhymes, number songs, silly songs. There's lots of number songs on YouTube, times table songs on YouTube. A teacher friend of mine recommends just having it playing in the background when you're doing your maths class. Before you know it, you'll be singing along and get it. And there's also a really lovely game called Radar Arrays, which we'll put a link for down below. And you can go and play that. And that doesn't just give you your times tables, it actually gives you, again, the patterns. You're looking for the patterns. The word used is arrays, and it's the patterns which we're going to look at next. Now, dun, 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 dun. I'm going to show you this sheet. So you either have to create this or you have to download it. And I say have to, that's a big word, have to. Hi Machachi. Actually, words go out well on the phone because I can see the messages. So we have sending love to you too. So we have these 10 squares, 100 squares. We've got 9 of them. There are 9 times tables. Oh, this goes up to the 10 times table, sorry. Yeah, there are 9 times tables because if we're going to colour in all the 1 times table, how much of this 100 square would we colour in? Yeah, we colour the whole thing in. So we only need to go from the 2 times tables. We're looking for patterns. We're looking for those arrays. We're looking for where everything happens and how it all connects to each other. So having it all on one sheet is a very useful thing. So we're going to do the 6 times table because that's already done for you on there anyway. So now let's see how we're going to do this. We're going to turn this around. Whoopsie. Don't separate the battery from the phone or we won't have a phone to use. Right, here we go. I'm going to stay up there. Thank you very much. Now you're going to turn around and let's see what we can see. I won't be looking at what you're looking at. So you don't have to see all the detail, but this is what the idea. We'll go for the 6 times table. So the 6 times table is 6. So let's say we were counting in 6s. We've got 6 and then 12. What's next? You tell me what's next. And then, and then 18, that's 3. And next is 24. And next is 30. And next is 6. Are you starting to see a pattern? And next is 42. This pattern repeats itself. At what point does it start repeating itself? 54. Whoopsie. 60. 66. 72, 78, 84, 90. Oh my goodness, I think I could just start doing this and just keep going and just boom, 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 boom. Where's the pattern? Can you see where the pattern repeats? If I took those 3 lines, do I have to actually know any more than those 3 lines? And what's happening? What's happening? We're talking about the shifting. We're shifting down 1 and across 1, 2, 3, 4. That one we're shifting down 1 and across 1, 2, 3, 4. We've got that one now. From this one, we're shifting down 1 and across 1, 2, 3, 4, because they wrap around. But if we had them on a continuous number line, you'd see it. So down 1. Oh, where did I go? Down 1, 1, 2. Wait, where are we? Sorry, 6 down 1, 1, 2, 3, 4 takes us to the 12. So we're actually going up. So we're going up, basically up 1. We're up, correction. We're going up 10 and back 1, 2, 3, 4. That's it. Now we're going up 10, back 1, 2, 3, 4. Here we go. Up 10, back 1, 2, 3, 4. Every single, of course, because it's a linear progression. We're just adding 6 onto every number. So if we were to put that onto that's the pattern, that's what we're looking for. And not just that, but once you get to there, it just repeats itself and repeats itself and repeats itself. So if you went up to 200, you would really see the pattern. And that's actually, yeah, so you've got the pattern up to 100, which takes you over your 10 times table, but it gives you the patterns, and that's what we're looking for, so that you get a feel for the numbers. And that way, when it comes to doing the times tables, it kind of is obvious. And one of the things I'm going to do, maybe on an evening session, is we're going to do the 17 times table. 17 times table. Why? You ask yourself. Are you asking me? You may not be asking. Why 17 times table? Because you think it would be super difficult. And it sort of is, but at the same time, it really reveals the relationship between all the numbers, and it just gives you a better feeling for how numbers work, and it gives you some agility in moving around numbers. Okay, next is something that is extremely useful, is to go ahead and do this, but instead of doing it on 100 square, just write out the numbers, and that's for all the times tables. Write out all the numbers from 1 to 150, all of them, every single one. So obviously 1 times table, you just write all the numbers. We don't need to do that. 2 times table, write all the numbers. You'll see the pattern. Maybe you don't actually need to do it, and well, once you see the pattern, maybe you do it. Maybe do it. Maybe do it so you can say definitely what the pattern is of every single number in the 2 times table, and there is one. There's something there's a rule that's always true of all the numbers in the 2 times tables. Then do it for 3s, and then do it for 4s and 5s and 6s and 7s and 8s and 9s and 10s and 11s and 12s. Now, why 11 and 12s if you don't have to learn your 11 and 12 times table? Well, 11's a really cool number anyway. 11's a super cool number. Actually, I would say take your 11s and go up to 200, because there's a pattern that happens between there's one thing that happens between 100 with 0 and 100, and there's something else different that happens between 100 and 200. It's for the same reason. It's because you're multiplying ones together. Well, ones, yeah, you're basically adding lots of ones together is what you're doing. You've just got groups of 1, so you've got 11, and so you're always multiplying by 1. And whatever amount, if it's 15 by 11, it's still 15 times 1 and 15 times 1, and it's got to do with that. And it's really cool. If you spot the pattern, you will actually know, you'll be able to know your 11 times table, and then you can say, well, what happens between 200 and 300, and go and test that out. And actually, you know what, while we're here, I'm just going to do something. I'm just going to give you a little, actually, no, I'm not. I'm going to make that. I'm going to make a note. And we're going to do it in the evening. I'm thinking up little activities we can do in the evenings. So we're going to do 1 times 1, 1. We're going to do the toilet paper challenge, and we're going to do, what did I just say we were going to do there in the, oh no! I said we were going to do something in the evening earlier, and I don't remember what it was. It's gone. It'll come back. At some point it'll come back. Okay, so, right, so those are the things for primary that will really, really help you learn your times tables, and definitely do find the silly songs, find the number rhymes, and we'll put the link on to down below when I've finished nattering away. Now, we're talking about shifting times tables. So, if you download the resource, the exercise for years, so everything we've done up to now will work for basically ages 7 to 14. And this also works for 11 to 14. So this bit here is for basically everybody early primary up to about the age of 14. So the best way to do this is actually to go ahead and download the resource, and it's based on looking at graphs. Now this was the surprise. What have times tables got to do with straight lines? What have times tables got to do with functions of straight lines? I ask you. Well, if you do the activity, it gives you a challenge to basically these talk about these lines here, and then it suggests that you make your own lines and work out. I'm going to hide that. Don't hide that. There you go. And work out what the functions are. Well, you don't have to necessarily. What you're looking for is, what do you notice, and how does C relate to D, and how of these three number sequences, which lines, if you plot what's happening there, so this is what's happening at 0. That first number is at 0, and then the next number, is it 0? Yes, the first number is what's happening at 0, and then the following numbers are wherever you put them on this chart, and that you can actually figure out which of these sequences match which of these lines. Now, and then you can make up your own. So those are things you can work out. So these all relate to a multiplication table, and you've got to work out which multiplication table it is. And you can do your own lines for all different multiplications and shift them. So you can position them differently by shifting the numbers. So the difference between the placement is the same, but they'll be shifted up or down. They'll start at 0, wherever the line starts at 0 will be different, and then the gradient of the line you draw will also, the two variables are two things that change. You can use for primary, Machashi's asking, will it be suitable for primary? This is aimed at secondary, and you can just plot the numbers, just keep the conversation really simple and do it more as you can do it. It's not, I don't think it's expected at primary, but you can do it as if you have a look at the arrays, have a look at the array, see how, if you use the link will be here, is that using the arrays for timetables. If you look at that, that'll give you ideas on how to use it in primary. You want to be keeping it super simple and keep the language simple. But there's no reason why you shouldn't actually see that if you plot a shifted times table, that it makes a straight line. Okay, Now, not going to go into much detail for the seniors, so that's 16 to 18-year-olds. But what the activity is to actually now write a function, to build a function based on a line that you draw. Now these are all straight lines, so it is quite simple, although you can shift curved lines. We're just sticking to functions where you're shifting times tables. Now I never ever clocked that you can draw a straight line with a times table. I think that would be quite a nice thing just to see in primary, that you can just draw a line, and that line you just literally every time you get to, and you can do it on a chart. That might be the way. Do a times table chart on the, yeah, and it just keeps going. Just do it, make it a times table chart, and you'll see it's just a straight line. Yes, I will. My chachi, you will get this link. This link's already up. I'll put it down here, and we'll do the one to the arrays. And that's a nice idea. Maybe doing an activity for primary, which is just on a chart, where it's kind of maybe done differently. Using this idea, using a chart that looks like boxes rather than dots, or not, or even just, yeah. We'll look into that. We'll look at that. Okay, so that is what you want to do. So if you're in 16 to 18, then just download the resource and do this activity. And the challenge is to make your own. So first of all, this is a nice simple way of showing how it works, and then make your own lines, make your own functions, and then you can test it. You can see if other people can work out what your function is. Now that is a game. Then there's the function game, which is a great game for early secondary. Which is, if you've got a function, you can say 2n plus 1. That's what's in my head. And nobody says anything. I was described this game last night, so I'm just describing it. So I'm not even going to say what the function is. Sorry. You give me a number, and I'm going to perform the function that's in my head, and I'm going to write down what the answer is to the function, and then you've got to decide what the function is. So that's a game that you can play, and it's a game that you can play over the phone if you're with. Certainly, you can play a game you can play with your class, or you can play between friends, and you can decide on a function. So I've got a function in my head. I'll write it down here so I don't forget it. Right. So give me a number. The number is 5. Okay. If the input number is 5, my function box comes out with input 5. My function box comes out with 17. Number 2. Oh, that's nice and easy. Number 2, put it into my function box. My function comes out with 8. Okay, whoops. Number 0. Oh, okay, 0. If I put in 0, my function box produces 2. And then to use the idea of plotting it, what you can then do is, if we don't have to stay with positive numbers. We can open it out to negative numbers. So the number that we're coming up with is here, and the number you're giving me is on this line here. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the input of the function box, and this is the output of the function box. So at 0, you put in a 0, and 1, 2, 3, 4, 5, 6, 7, 8. If you put in a 0, it's 2. So at 0, is that correct? I think that's wrong. If you put in 0, it's the other way around. This is in and that's out. If you put in 0, I'm doing it again, ad-libbing. Putting in 0, you come out with 2. If you put in wait a minute, my brain. I'm going to work out which is which in a minute. So if you put in 0, it goes to 2. If you put in 2, that's it. If you put it is in, this is in. Yeah, if you put in 0, so it's 0 there, that is out. If you put in 0, it outs at 2, comes out at 2. If you put in 2, it comes out at 8. 2, 4, 6. Oh dear, 8. I haven't made it big enough. If you put in If you put in 3, it comes out to if you put in 1, that's what I meant to put in there. If you put in 1, it comes out to 4. So it's, if you put in 1, so if we're here, 1, 2, 3, 4. 1, no, it doesn't, it comes out to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It comes out there. At 1, it comes out there. There you go. And at 2, it comes out up there. So you can, and you down here, it would come here, and further up here. At 5, it comes out at 17. 2, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17. It's about there. And you will find that that is a straight line. So I don't know. Check with Tony, but but you can do this. You can see what happens, but I'm not. This is not a primary activity, but that's how you would introduce it anyway. And you can use your function box to actually plot and predict, and then see what I'm doing to. Because this is now shifted. This is a times table that has been shifted. It's been shifted up at 0. It's up at 2, so it's been shifted up by 2. So that's how you would use it. I'm not sure that we want to shift times tables at 2. Check with your. That's not my speciality. I kind of dive in where I go, and I'm doing my best to present this, and I'm presenting. I did finish, and that would be suitable for what I was talking about. Would be suitable for the upper secondary anyway, so that's fine. Okay, cool. I have to stop ad-libbing. Mind you, that's what the lives are for. The lives are for ad-libbing, and then we're going to be starting probably in the next couple of weeks. When we do these lives, we will have already produced the video for Maths Toys, and the Maths Toys videos will match very systematically, in an organised way. They will match the resources on the Aiming High website, so they will all be down there. So if you please subscribe to the Maths Toys, so that when the videos start loading up, we've already got a few on there with some lovely activities with Tangram and a couple of other activities on there. So there's some great things you can already do on the Maths Toys. So that's youtube.com/Maths Toys, and we'll put the links. Will all go down in the description, and then there's the Bubbly Maths one, the YouTube Bubbly Maths channel. Will have all of these videos, the crazy lives that I'm doing, and then the AIMSEC YouTube page has lots of activities if you just want to have a moment of fun. It's just some thought-provoking maths ideas, and then the Aiming High website itself has just loads and loads and loads and loads of activities. Some are just pure games. Well, none of them are pure games. They're all maths games, but they are games. Most games are maths games. They're all everything. There's maths in everything. There's maths in everything you do anyway, and and please join us. So in 25 minutes, we'll be doing another live for the early years, specifically for the early years. And then at 8 o'clock tonight, we'll be introducing tomorrow's concept, which is all about weighing things. It's about how much things weigh and how to play with it and work with it, and going again all the way from early years, activities from early years to upper secondary, to upper high school, as in 18-year-olds. Thank you. And now, I can just finish this one now. I don't have to go kerfuffling all around. It means I haven't shared it anywhere yet. I'll have to share it afterwards. But I just get to press a button now. Oh, wait a minute. I'm going to press this one first. Didn't work. My easy button isn't working. That's terrible. It was working yesterday.
That was easy.
Oh, did you hear it?
That was easy.
There you go. Thank you very much. See you. Oh, you're very welcome. Thank you, Machachi. And we'll see you at 10 if you want to join us for 10. 10 for the early years. Thank you. Bye.